In today's note, we are going to be looking at acute triangle trigonometry. Specifically, we're going to be looking at the sine law and solving for side lengths. So before we begin, can we use SOHCAHTOA to solve the following triangle? Why or why not? So looking at this triangle, I'm given a side, I'm given two angles. And if I want to solve it, I want to find all the other angles and all the other sides. So I can solve for this angle, because all angles in a triangle have to add up to 180 degrees. So 180 minus 38 minus 59 gives me this unknown angle, which is 83 degrees. So I know what this missing angle is, but now I need to find the two other sides. So if I'm using SOHCAHTOA, I need to label my sides as my opposite and adjacent, and my hypotenuse. However, in this case, I have three angles that I could use as a reference, which is fine, but I don't have a right angle to help me label my hypotenuse. So that's where it becomes tricky. I cannot label the hypotenuse because I don't know which one it's going to be. And we know that the hypotenuse is always across from the 90 degrees, and if there is no 90-degree angle, then there can't be a hypotenuse. So I cannot use SOHCAHTOA for this. So no, we cannot use SOHCAHTOA. And the reason, it's not a right angle triangle. In other words, there's no 90-degree angle. So if we're dealing with triangles that do not have a right angle triangle in them, or non-right angle triangles, we need to come up with something else. So when dealing with acute triangles, or non-right angle triangles, one thing that we can use is the sine law. And we can use the sine law to help us solve for missing sides and angles. In this note in particular, we're going to be focusing on just finding sides. So what the sine law is, it's a ratio of angles and their corresponding sides, or all the angles and their corresponding sides. So we can see down here, sine A over little a equals sine B over little b equals sine C over little c. Or you could flip all the fractions, and it's the same thing. Little a over sine A, little b over sine B, little c over sine C. Either way you use it is up to you, but it works out in the end. The key thing is, though, just make sure that when you're using these two variations of this, you keep in mind that the capital letters represent the angles. Right, so here, these capital letters are the angles. On top, they're over here. And the lowercase letters represent the sides. So as long as you're okay remembering that, then it doesn't really matter which form you use. However, the steps are going to be the same regardless. So basically what these are looking at, we've created pairs between all the angles and their corresponding sides. So for example, this is one pair of angle A and side A. This is a pair of angle B and side B. And this is our third pair of angle C and side C. And what the sine law is basically telling us, that when we do sine of the angle over or divided by its corresponding side, that's equal to the ratio of sine of another angle and its corresponding side, which is also equal to that last pair, or the ratio of the last pair. So when we're solving for a missing side, we need to be given two angles and a side. And this will basically be equated to, or be visualized as, a full pair, or one pair and half a pair. So say the angle and the side is its full pair, and then the other angle and its unknown side is the half pair. One thing to be aware of, you're only going to be dealing with two pairs at a time. So we see in the sine law here, there's two equal signs because we're equating three ratios. When we actually go through and use the sine law, we're only going to be dealing with two pairs at a time, so you won't have to worry about navigating an equation with two equal signs in it. There's only going to be one because we're only going to be dealing with two pairs. So if we look at the first example, we want to use the sine law to solve for the missing side length. First thing I want to do is check, is this a 90-degree triangle? Based off my first two angles, I could solve for angle x. Might as well do that now anyways. So 180 minus 63 minus 44 equals 73. So none of these angles are right angle triangles, so I can't use SOHCAHTOA. That leaves me with my sine law for right now. And I can see that if I create pairs, I have a full pair there, and I have a half pair here with my unknown side. Yes, I could have also considered that angle x and side x create another half pair now that I know what this angle is, but based on what the information that was given to me at the beginning, I'm going to be solving for side z. That's the unknown, that's the missing side length that I'm looking for. But again, we could do this and solve for angle x as well if we wanted to. So now that I have my full pair and my half pair, I'm going to start by writing out my sine law. So sine of the angle, or in this case z, over side z is equal to sine of my angle, in this case y, over its corresponding side, little y. I'm not going to worry about angle x because, again, I'm not looking for that one. If I wanted to, I could again go back later and do sine y over little y equals sine x over little x. Again, I have to use sine y and little y because that's my full pair, because I have both pieces of information for that pair. Once I write out my sine law, I'm going to fill in my missing information, or use my given information to fill in what I can. So sine z, or angle z is 44 over my unknown side. Sine y is 63 over side y, which is 22. Once I've filled in all my information, I'm going to cross multiply to get rid of the fractions. So 22 times sine 44 equals z times sine 63. To get z by itself, I want to move the sine 63 over. Because I'm multiplying by sine 63 on the one side, when I move it over, it becomes divide by sine 63. Z's by itself, so now I can solve this one side to get my final answer. Because again, sine of an angle just becomes a number, like we've seen in the past. If you want, you can do this all in one step on your calculator, or you can go through it step by step, simplify the top, where you get 15.282 divided by sine 63, which is 0.891. Let me just move this up. And then we can solve for z by just dividing the two. If you are going to do it step by step and solve or simplify the top first and then the bottom, again, please keep a couple decimal places just to make sure that you're not rounding too early, because that could change your answer a bit. And in the end, you should get that the missing side length is 17.15. Again, make sure, if you're separate, or if you're doing it in full steps and you're simplifying it step by step, not doing it all at once on your calculator, keep a couple decimal places and make sure your calculator is in degree mode when you do this. So that's how you use the sine law to solve for the missing side length. So for B, I'm going to let you try this on your own, but before we do that, I'm going to help you out a little bit, because if I'm trying to solve for side C, I know this has to be one pair that I'm using, because that's the unknown side that's indicated. I do see a full pair here between angle B and side B. However, I don't have enough information in pair C to solve. I'm missing what this angle is. And if we go back up to the first page, again, we needed that full pair and the half pair, which was basically two angles and one side. So I need to find this missing angle here. Luckily though, I do have two angles in this triangle, so I can do 180 minus 47 minus 84, which will give me that unknown angle, which is 49 degrees. So now I do have enough information to solve for the missing side length of C. So again, I recommend you pause the video so that you can try this on your own, and we'll come back with the solution. So coming back to our solution, again, sine B over little b equals sine C over little c. That should be the sine law that we're using because we're dealing with these two pairs, or the ratio of these angles and sides. Fill in using our given information, cross multiply to get rid of our fractions, and then we solve for C. We should get then C equals 106 times sine 49 divided by sine 84. Here you could do this entire step right here on the calculator if you wanted to and go right to your final answer. Or you could break it down, simplify the top, simplify the bottom, and then divide your two numbers. In the end, you should get that side C is 80.4 units long. Again, if you are using your phone, or if you're or maybe a more simple scientific calculator, you probably will have to do it in parts. Simplify each the numerator and the denominator, and then divide. Again, depending on your calculator or your personal preference. As well, make sure that it is in degree mode when you're solving or calculating trig questions as well. But again, the steps are the same as the last example with the cross multiplying and the solving. You will maybe notice that we put sine B, or the B pair first over the and the C pair second. In the end, that doesn't really change anything. The only difference is that when we get to the end, when we're solving, our unknown is on the left side instead of the right side, like the last example. But in the end, it doesn't really matter because you're still going to be isolating for that unknown variable, and the steps are still going to be the same. So if you prefer to have your unknown on the left side, then you may want to put your full pair on the left side. If it doesn't really matter to you, then it doesn't really matter which pair you set up with, right? So we could have done sine C over little c first and sine B over little b second, and it just would have been reversed, but the steps would have been the same. The next thing we're going to look at is a couple of word problems. Again, I'll go through one example with you, and then I'll let you try one on your own. So an architect designed a house that is 12 meters wide. The rafters that hold up the roof are equal in length and meet at an angle of 70 degrees, as shown at the right. The rafters extend 0.3 meters beyond the supporting wall. How long are the rafters? So if I look at my diagram, I know how long the rafters are beyond the supporting wall. So in other words, I just need to know how long are they up into that supporting wall. And if I know that length, I can add it to 103, and that will give me my full length of the rafters. I can see by looking at the diagram that I have a full pair of an angle and a side. However, I am missing my half pair. I already know that my side should be unknown, but I don't have this angle here. If I were to isolate the triangle on its own, again, we know 70 is up here, there should be some more information from our question. The question does tell us that the rafters that hold up the roof are equal in length. So that means that these two sides on our triangle are equal. And if they're equal, then that means this is an isosceles triangle, and I should be able to figure out what my two unknown angles are. Because again, all angles have to add up to 180, so 180 minus 70 equals 110. So that means these two angles, the two bottom angles, have to add up to 110, and they have to be the same because it's an isosceles triangle. So 110 divided by 2 equals 55 degrees. So I know what my angle is, or what my two angles are actually. I could have set it up so that pair was the other one as well. Again, it doesn't really matter because both sides are the same, both angles are the same. So when I calculate, I should get the same answer. So now I have my full pair and my half pair. So I'm going to write out my sine law. In this case, the triangle's not labeled, so I'm just going to use A and B for my two ratios, as long as I keep it consistent on what I plug in. So for example, sine A, I'm going to say that angle A is 70 degrees, which means that side B has to be the corresponding side, or 12 meters. Sine B, B is going to be 55 degrees. So when I look at my triangle, that corresponding side, is X, or my unknown. Once I've plugged in all my information, I'm going to cross multiply to get rid of the fractions. X times sine 70 is equal to 12 times sine 55. Get X by itself, it becomes 12 times sine 55 divided by sine 70. Again, you can do this all at once on your calculator, or you can break it down into two steps. Simplify the top, simplify the bottom. Either way, in the end, you should get 10.5 meters as your length for X. Now that you know what X is, you can find the length of the rafters, the full length, because it will equal X plus 0.3 meters. So we get 10.5 plus 0.3 equals 10.8 meters. So therefore, the rafters are 10.8 meters long. In the next example, Scott is a naturalist. He is studying the effects of acid rain on fish populations in different lakes. As part of his research, he needs to know the length of Lake Labarge. Scott makes the measurements shown. How long is Lake Labarge? So looking at our triangle here, we have some information, and we're looking for this length. So again, I'm going to pause the video and give you a chance to work through this. Again, try to solve for that unknown side. You may have to do some small calculations before you use the sine law. So again, see if there's anything you can do kind of quickly, and then see how you can apply the sine law. And we'll come back with the solutions. But again, before we jump into that, today's code word is apple. Again, today's code word is apple. So again, remember to go to the course quiz just to verify that you've been going through the videos. So again, like I said, I'll suggest that you pause the video and we'll come back with the full solutions to this question. So coming back to the video, or to the solution, sorry, we should have been able to find angle A by using the idea that all angles in a triangle add up to 180, so that we get angle A is 80 degrees. From there, we have now a full pair of angle A and side A, and half a pair of angle C and side C. We do have half a pair with angle B and side B as well. However, we're not looking for the length that side B gives us. We're looking for side C. So in our sine law, we're using sine A over little a equals sine C over little c. Plug in our information that we have from our question. Cross multiply to get rid of the fractions. And now we're solving for our unknown, or x in this case. Again, you can do this once we rearrange. You can do this all as one step on a calculator, or you can do it step by step. Simplify the numerator and then the denominator and then divide. In the end, though, you should get that your angle, or your unknown length, is 3,275. So therefore, the length of Lake Labarge is 3,275 meters. Again, same steps that we've been looking at. Again, the order that you put them in, the order that your ratios go in doesn't really matter, because in the end, you're still going to be rearranging and cross-multiplying to find your unknown. If you are going to break it down and simplify the numerator and denominator first before you divide, just make sure you keep a few decimal places. Depending on your calculator, you may have to do that. If your calculator is strong enough, you could do it all in one step. If not, that's fine. Just take your time with it. And again, make sure your calculator is in degree mode when you're doing this. But again, the main thing from this lesson is just to make sure that you understand how to use sine law to solve for a missing side length.